Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 3, graphing. We're still doing intermediate algebra, and the book we're using is the one from Ellen Martin Gray, Intermediate Algebra, 8th edition. So in the previous videos, we went over the first three sections. We introduced the graph of inequations, introduce you to functions, and graph of linear equations. Remember, linear equations is a straight line. But you may notice by now that different lines often tell differently. But so far, as we said, for line graphs that we said linear functions, most of all, those lines may be vertical, horizontals, and sometimes they're not. They are neither vertical nor horizontal, but they are oblique. It's like a slant. So when you have a slant, at some point, this graph has what we call the slope. Okay, it's very important in many fields to be able to measure and compare the slope of a line. The slope of a line is like we say, why the graph is not that straight vertically or horizontally. So actually, that's what we're gonna do in section 4. We're going to study the slope overline. So in this section, our objective is to find the slope of a line given 2 points on the line, or finding slope given an equation in the slope-intercept form. I can start very quick to say that you're going to see why this equations right there, like sorry for that, y equal mx plus b. What's the number in front of x represents? That's what we're gonna do. Find the slopes of horizontal and vertical lines. That means when you have only a vertical line or a horizontal line, what would be the slope? And compare the slope of a parallel or perpendicular line. So that's what we're planning on doing. But let's start first of all with the definitions of a slope. We're going to find the slope of a line given 2 points on the line. Okay, so we said that the slope m of the line containing 2 points, the slope m of a line containing 2 points, we said x1, y1, x2, y2 is given by this beautiful formula because what we call the slope, for example, I'm going to show you. Suppose we have a graph on a xy plane is a straight line. Suppose on the straight line we have a value x1. When you plug this x1 in the graph, it gives you maybe a y1. So remember, this point right there is the point x1, y1. Or if you have another point like x2, when we said x1, x2, they are constant, they are real numbers, numbers you plug in the functions you have to obtain y. Let's say y2. When I plug x1, it gives me y2. Okay. So for me, this graph right there, this two line like this, okay, or maybe keep going this way, but for these 2 points, because the slope right there, as you can see, is like the rate of change. It's kind of the rate of change. Now, in order for me to find the slope of this line, remember what we said. This distance right here, you see, is between the two values of x. Let's say down here, if we call it only is the change of x, like here. You see this distance right there, that would be x2 minus x1. And this distance right there would be between these two y's. Remember, you have these two y's. So it's y2 minus y1. So we can say that the slope of that line, why this line is not totally horizontal or vertical, is because of that difference. So we said is a rise, that means going up, that's a rise over the run. So if you have a rise and a run, then you can have that slope going like this. Okay, so that's why we said that M, that we call slope. So is the slope of the line. We call M is the slope. So M is rise over 1 or change in Y. That means the two values of Y over the two values of X. So this is a formula that you need to write somewhere because you're going to need it from times to times when you do algebra. You either need to remember all the formulas or you need to write them somewhere from time to time. So take a look on this. All right. Let's see very quick in an example where we have find the slope of the line through 0, 3 and 2, 5 and graph the lines. So the first thing to do in this case for us is really we need to use the slope formula because we have 2 points. If you want to call this one x1, y1, x2, y2, okay, you see you have these 2 points. And remember the formula we have for that, we call it slope is y2 minus y1 over x2 minus x1. But they said, find the slope. The first thing is to use the slope formula. It does not matter which point we call x1, y1. I call the first one x1, y1, but if you want to call x1, y1 with the second one, that would be fine. Okay, so the second things I would do is to plug. Remember, y is always the second coordinate. So we said y2 is 5 minus y1 is 3 over x2 is 2 minus 0. So you see we have 2 over 2. All right. Now that's what we have. We can leave it like this, or we know 2 over 2 is 1. So slope M is 1. Okay. Now, when they ask you to graph, remember if I consider these two lines straight, remember the first point we have when x is 0, y is 1, 2, and 3. This is 1 point right here. When x is 2, 1, and 2, y is 3, 4, and 5. Okay. Now, you can take multiple other points, but I have enough to know that my graph would go through these 2 points. Sorry. Mhm. I would assume this is my graph. You see? So because the slope of this line is positive, remember, M is positive. When M is positive, then when the slope is positive, graph the graph rise from left to right. M positive graph rise from left to right. Okay. Now M negative graph falls from left to right. Okay, from left to right. So when any times we do that, if M is negative, the graph falls from left to right. So I think we have both. When we're working with the slope, the first thing is to identify if you have 2 points. The 2 points you have, you need to identify which of these 2 points would be the first one where you would consider x1, y1, and the second one would be x2, y2. Now, the slope is rise over run. That means the difference between the y's over the difference between the x's. Now, is this slope, once you compute the slope, is this slope is positive, then the graph rise from left to right. If the slope is negative, the graph falls from left to right. So I think we're gonna continue with the same examples, but look at this one. When they ask you to find the slope of the line containing the points, again, if I call the first point x1, y1, so x1 is 4, y1 is -3. And for the second point, remember one point has two coordinates, one coordinate of x and one coordinate of y. The first coordinate is always the x coordinates, all right? You cannot consider the first coordinate as y, especially when you have parentheses. Parentheses means the coordinates inside of the parentheses are for x and y. Now, because I identify my 2 points, I know the slope m would be y2 minus y1 over a x2 minus x1. You see, I do both. Uh, x2. Now, what we're gonna do is 2 minus minus negative 2 over 2 minus negative 2 over 2 minus 4. So that would be 2 plus 2 over -2. 4 over -2 equal -2. Now remember this slope right here, as you can see, it's really negative. When I graph, I would already see the graph would fall from left to right, okay? So you will see the graph would fall from left to right. Let's graph it here. So we're gonna have on the graph where we need to identify the first point, 1, 2, 3, and 4, a -1, -2, and -3. So we know our first point is right there. And the second point, when x is 2, y is 1 and 2. This is the second point right there, okay? Now, I have these 2 points. Remember these 2 points, we can see them right there. I don't know why I said, I think this one was incorrect, right? Because I have, it's not -2, it was -3. Okay, -3, that would give you a +3. That would give us 5 over 2. That would give us -5 over 2, and that would give us -5 over 2 as the slope. That means that, you rise 5 coordinates and you run 2 coordinates. So if you want to see here, look at when we say rise 5. If you fall 2, so that means from here, you can say 1, 2, 3, 4, and 5. Okay, so you see between these, we have the 5. And fall 2, look at between these two, 1 and 2. So that's what we said. That's what the slope does. Okay, the slope works that way. All right. Now, when you look at this one right there, we have our point. We can go like going down like this if we want. This is our graph. Remember in the previous slide, I said M negative graph falls from left to right. You see for this graph, because we have that negative sign right here, we would say it falls from left, we would say it falls from left to right. That's very important to take it this way, okay? That's very important to take it this way. The access to find the slope, we find the slope is negative. Then once we find the slope negative, we know the graph would fall. So when finding slope, it makes no difference which point is identified as x1, y1, and which one is x2, y2. Just remember that where the y values is first in the numerator, it's corresponding to x value is first in the second quarter. So we're gonna try to do it this way for everyone, okay? Then what we're gonna do, we would graph another one. But before we even get there, how about we just look at a few definitions because this slope-intercept form, when we start the slope-intercept form, knowing that when a linear equations is written in the form, we can write the linear equations in the form f of x equal ax plus b. If you want to write it ax plus b, the ab, remember those are numbers, but we prefer to write it f of x equal mx plus b. Or you can write it y. Remember we said anytime you said f of x is the same thing we call it y. So y mx plus b is a different way of writing exactly the same thing. Now, the coefficient of x any times is written in terms of y equal mx plus b, the coefficient of x, which is m, is the slope of the line, and 0b is the y-intercept. So if I have y equal mx plus b, m is the slope, the y-intercept is b, 0b is the y intercept. So y equal mx plus b is appropriately called the slope intercept form. So that's why exactly what we write there. We said when a linear equation in two variable is written in the slope intercept form y equal mx plus b, we said m is the slope and b is the y-intercept. Okay, well, we know this one would be the y-intercept. So that's something you need to know anytime it's happened. We said y equal mx plus b, b is the y-intercept. So that's very giantly important to see it that way. M is the slope and 0 is the y-intercept. Now let's go with some examples very quick because we need to see how to find the slope and the y-intercept in this one. Remember what happened. We must have y equal mx plus b. Okay, so we have 2y. We need to solve, sorry, I need to solve for y, because here when I have negative 3x plus 2y equals 11, on one side, you must have only y, okay? Um, uh, uh, So sorry about that. Sir. So on this side, we need to isolate y. Make sure y is on one side by itself. So what you need to do, plus 3x, okay. So 2y equal 3x plus 11 because I solve for y, because I only need y on one side, only y. We cannot have more. So what I do, I divide everything by 2. So we end up having y equals 3 half of x plus 11 over 2. Now, what is the slope? The first thing to do, we add 3x from both sides, then we divide both sides by 2, okay? Now we simplify. Now the coefficient of x, 3 half, is the slope. So we're gonna say slope m is what? 3 half. This is the slope. What would be the y-intercept? So what is the y-intercept? They don't ask us for it, but you should see it. Y-intercept is what? Y-intercept, yeah, x is always 0 in y-intercept, okay? And yes, 11 over 2 is the y-intercept. We're going to go very quick with some other examples. Look at this one. We have negative y equals 6x minus 7. Okay. We have negative 6x minus 7. That's very important to see. First of all, we must have only y, not negative y. So what I'm going to do, I'm going to divide everywhere by negative 1, negative 1, negative 1. Or I could multiply also. So I end up with positive y. One negative, one positive give you a negative 6x. Two negative give you positive 7. Now, what is the slope? Remember, the slope, we solve the equation for y not negative y. We are certain that's what's going to happen. Now, after we do that, we need to identify our slope. M coefficient of x is the slope, and the y-intercept is b. So what is the y-intercept here? But if you said y-intercept, I mean x is 0, y-intercept is 7. So would this graph rise from left to right, or would this graph falls from left to right? It's going to fall from left to right. Do you know why? It is simply because the slope is negative, then we know we're going to have a negative slope. Now, interpreting the slope in real exercises. So how you would interpret slope-intercept form? Look at these examples. They tells you that the adult one-day pass price Y for Disney World is given by an equation. So you know what? I'm gonna just, if it's possible, make it smaller so we have enough space for it. Okay, I apologize for this. But look, we have Y equal 3.53x plus 67.39 is the equations, okay, that give you the adult one-day pass price, okay? So to predict the price of a pass in 2026, okay, remember here they said where X is the number of years since 2006. Remember, 2006 was the first year, 2007, 2008. But look, if you said use the equation to predict the ticket's price for 2016, so you know what would be X again. So you know 2026, okay, 2026, 2026 minus 2006 give you 20. So we need to look for it for 20 years. Okay. I don't know if that's okay for you. So the other one day, the other one day pass price Y for Disney World is given by this equation. To predict the price of a pass in 2026, we need to find Y when X is 15. Is that 15? Because we said we start with 26. No. When x is 20, sorry, we need to find it when x is 20 because 2026 minus 2006 gave us 20, okay? Remember at 2006 it was 0, so if you count to 26, it's gonna be 20. So we know the pass would be y equal 3.53 times 20 plus 67.39. So when you do this computation, price would be $139.99. I put dollars on the bottom. Okay. Use this equation to predict the ticket price for 2026, so 20 years later. All right, that's the price for the ticket. Okay, is that correct? Because if you know what was the price of the ticket in 2006, So the tickets for 2026 is $137.99. But in 2006, remember, it's the initial year. That means at that time, X was zero, so Y would be only 3.53 times zero is zero. The tickets was only $67.39. So that was the price for the ticket in 2006. And now in 2026, then the tickets like more than double. No, a little bit less than double, right? Okay, I think we're good with that examples, and it's very important to see very quick how to find slope of horizontal and vertical line. You see for this line where you only have x equal -2, knowing that x equal -2, all solutions must have a x value of -2. So that means we know what would be y. No matter what is y, x would always be -2. How to see it? Look, do you feel like you have a slope? Because this is -1, -2. There is no slant. Your graph is no slant because x would always be -2. So that means y would be zero. The slope is zero. So why we would say that? Because any point in solutions, let's say if we said x1, y1, x would be -2. I can choose any y, okay? Or if I said x2, y2, and I take another point, remember x would always be -2 even though I decide to change this one, let's say -5. So if x -2, y -3, 1, 2, and 3, it's gonna be here. -5, 1, 2, 3, 4, and 5 should still be there. So we would conclude the slope of the line x equal -2 is undefined. Okay? Because you see it would be undefined. Why? Because if you do -5 minus 3 over -2 minus -2 would be -8 over -2 plus 2, -8 over 0. Remember, you cannot divide by 0. So if you have any values for x, know that slope is undefined. So slope would be undefined, okay? All vertical lines have undefined slope, okay? Very important. The slope of a vertical line, undefined slope. A vertical line has an undefined slope, of course, m is undefined. For any 2 points, the x values will be equal to the same real number. The denominator in the slope formula is 0, the difference of the x coordinates. But the numerator is not 0. Two different numbers would have two different x coordinates. So the slope is undefined. You cannot divide by 2. Now look at this one. That would be the horizontal slope. Very important to verify. If you try to graph y, you know it's gonna be a horizontal line. Y is 1, 2, and 3. Remember, we don't have any x values. So y is 3. Note if you want to do 2 points, x1, y1, like you do, because you can take any. Let's say -3, 3, or you say x2, y2, or we can say any y's, any x's. Sorry, I have y is 3. Let's say x is 1, but y would still be 3. So what we can do is 3 minus 3 for the slope. 3 minus 3 for the slope. And then we have 1 minus -3. So that would be 0 over 4. You see, it's 0. So slope for any 2 points, you can say the slope of the line y equals 0 is 0. So slope is 0. All right. All horizontal line has a slope of 0. We said 0 Slope, horizontal line, for any 2 points, the y values will be equal to the same real number. The number in the slope formula equal to 0, the difference of the y coordinates, but the denominator would be different because two different x would give you different numbers. So appearance of a lines we've given. Slope, we said positive slopes rise from left to right, negative slope falls from left to right. We already talked about it. We also have forgot to mention about the other ones like the parallel when you need to compare parallel lines, the slope of a parallel a perpendicular. Two lines that never intersect are called parallel lines. So that's something you need to remember in terms of different slopes. So if you have two lines that would never meet, we call them parallel. So parallel lines have the same slope and different y-intercepts, right? So for example, you have 2x minus 1, y equal 2x plus 6. These two lines, they are parallel because the slopes are the same, the coefficient of x are the same, but the y-intercepts are different. Two lines that intersect at different angles are called perpendicular lines. Two non-vertical perpendicular lines have slopes that are negative reciprocals of each other. So that means if you take the slope would be negative b over a, all right, for one of them, and the other one would be a over b. So remember that would be the slope is -1. Okay. Determine whether the lines, I think I need to go a little bit faster on these ones. Determines whether the line 6x plus 2y equal 9 is parallel to negative 3x minus y equal 3. The first thing to do here is to make sure we rewrite them. We solve for y in both. So equation 1, you have 6x plus 2y equal 9. If we subtract 6x from both sides, we have 2y equal negative 6x plus 9. If we divide by 2, every term by 2, we have negative 6 divided by 2 is negative 3x plus 9 half. Don't focus on the y-intercept. We focus only on the slope, the coefficient of x. For the second equations, we have negative 3x minus y equal 3. If we add if we add 3x on both sides, we're gonna have negative y equal positive 3x plus 3. If you multiply by -1, y would be negative 3x minus 3. Again, as you can see here, slope of both lines are -3. Slope of both lines are m equal -3. The y-intercept are different, so the lines are not the same. Therefore, the lines are parallel. Y-intercept different. Are different. So lines, we can say the lines are parallel. Okay. Hope, hope you got it. Hope you did it. Right? That's very important. That's one of them that we can do. You see, for perpendicular, we said determine whether the lines are perpendicular. Sorry, lines. We said the two lines, two non-vertical lines are perpendicular if the product of the slope is -1. Product of the slopes. So, meaning if you take the slope, if you take the first one, x plus 3y equal negative 15, 3y equal negative x minus 15, y equal negative 1/3 of x minus negative 15 over 3 is 5. So slope m is negative 1/3. So that's the first one. I'm gonna call it m1 for number one. Two, we have negative 3x plus y equal negative 1, adding 3x to both sides, y equal 3x minus 1. So m2 equal 3. Now we said two non-vertical lines are perpendicular product, if the product of the slope is negative 1. Now we're gonna just take the product. So the slope they are not the same, and the product is what? Let's do the product. If we take negative 1/3 times 3, would that give you negative 1? Yes, we can say that because these two really give us the slope are negative reciprocal, and so the lines are perpendicular, because the product of the two slopes is negative 1. The line are perpendicular. Voila, voila. We're gonna do one more exercise at this point just to make sure we have enough fun with these sections. It's to determine whether the following lines are parallel perpendicular. So we have two lines. So even for this one, having two lines right there, the first thing to do is really to solve for each of them. The first one, we're gonna have y equal 5x minus 6. So the slope is 5. For the second one, I'm going to call it M1. For the second one, we have 5y equal negative x plus 5. So solve for y, we're going to have negative 1 over 5x, okay, plus 5 over 5 is 1. So slope M2 is negative 1/5. First of all, you can verify that the slopes are different. M1 not equal to M2. Lines are not parallel. That's the first one. The second one is to verify for perpendicularity. So perpendicular product M1 times M2 equal 5 times negative 1 over 5 equal negative 1. Lines are perpendicular because if the product is equal perpendicular, okay? If the product of the slope is negative 1, then the products it's perpendicular. So this is what we're gonna do. We're gonna stop here for now, but in a different video, we're gonna come back with equations of the line. Hope you had fun with this one, and let me know if you have any question. Take care.